In this video, I'm going to talk about Excel financial functions, and it's the financial functions that are most useful in your personal life, whether you're dealing with loans or investments. Now, before we get started, you have to understand the time value of money. The notion that a dollar today is not worth the same as a dollar a year from now. Or I should put it, the dollar a year from now is worth a lot less than a dollar today. So how does that work? Here's my example. We're going to just have a nice round number, a 10% interest rates. And that's why money has a time value, is because you can use it to generate interest. And if we invest $100, and we're going to do it for 10 periods, now that's whether it's 10 months or 10 years, the bottom line is it's 10 periods earning 10%. So we can do the math. At the beginning of period 1, we have $100. At the end of period 1, that $100 is able to earn 10% interest for that period. So there's my formula, just taking 100 and adding 10% to it, right? So I'm at 110. So at the beginning of period 2, obviously, we start with $110. After generating a 10% interest rate on that, we are at $121, etc. Through the 10th period, we have, at the end of 10 periods, $259. So we were able to double or more than double our money over 10 periods if we were earning 10% interest rate. So given a 10% interest rate, $100 today is worth $259.37 10 periods from now. Let's just say this is years, so 10 years from now. Or another way of saying that is $259 in 10 years would be worth $100 today. Okay, so we have functions in Excel that will do this for us without having to go through and generate all these calculations for each period. So for instance, there's one called future value, and you type equal FV, and all of these functions have the similar parameters. So future value, what is money today worth some time period in the future given a certain interest rate? So in this case, we're going to take the rate as a 10%. NPER is the number of periods. How many periods are we talking about? In my example, we've got 10 periods. Are we making a payment? Like, are we continuing to do $100 every period? And in this example, the answer is no. We are not making a payment. And the present value. How much do I have today in the present? Well, that's the $100 that we're investing. Now, realistically, when you take that $100 and invest it, you're taking it out of your pocket and giving it to somebody else. That has a negative dollar sign as a convention that really doesn't matter too much. It just means your future value will have a positive dollar amount. If I don't put that negative sign on it, I get the same answer. It just comes out to be negative. So it's all about which way is the money going. When it goes from your pocket to a bank, that's negative to you, positive to the bank. And then when the bank gives you your investment back, that's positive to you and negative to the bank. So the number stays the same in any case. And so that's kind of not that important. But here's the bottom line. This future value function that said, hey, if you take $100, invest it at 10% for 10 years, what's its future value? $259.37. That's the exact same thing we got right here. Okay, so now we can do this and say, hey, what is some future value worth today? What is its present value? So equal PV is the function we want to do. Return the present value. And you'll notice things start looking the same. What interest rate are we dealing with? 10%. How many periods are you dealing with? 10. And are you making payments during these 10 periods? Nah, we're not in this example. And what is the future value? Oh, it says $259.37. And the type is normally an investment. You make them at the beginning of the period, so it's a 1. And you hit enter. And guess what? It's that $100. The present value, again, whether it's negative or positive, it's the $100 that you're going to invest to the bank. If I want to make it positive, I could have made the future value negative. Doesn't matter. But again, notice we're getting the same answer. There's a function that lets us calculate what interest rate we need. If I start with 100 and end with 259.37 10 periods from now, what would the interest rate need to be? So it's equal rate. And parenthesis, the NPER, or how many periods are we dealing with? 10. Did you make payments during those periods? In this example, no. What is the present value? Now, this time sign does matter, and that we are giving money to the bank, so that's negative. And comma, the future value is the money coming back from the bank or wherever invested, right? That has to be positive. So the bottom line is these need different signs. Whether you switch the signs is irrelevant. The number will be the same. And the type is 1, beginning of the period. And we hit enter. And woohoo, 10%. Well, that's interesting. That's the value that we started with. And finally, same thing. You kind of get the idea now is, what if I want to know, if I start with 100, I end up with 259.37 and I invest at 10%, how many periods do I need to get to that 259? And we can calculate that with the NPER function, number of periods. So, parenthesis, the rate 10%, comma, our payment, no, we haven't made any. Ooh, careful with the sign. The money leaving our pocket should probably be negative. The point here being it just needs to be different between these two. The future value we'll have as positive, and our type is 1. So when we hit enter, obviously we're going to get, you need 10 periods to go from 100 to 259 at 10%. So in each case, each one of these functions just solves for a different piece. So it all depends on what do you know and what am I trying to figure out. So let's use these functions in another example. This is more of a business example. Let me zoom in just a little bit here. I am trying to get a business loan, and so a bank handed me $750,000. When I'm done paying it off, it will be 0. I want to pay off this loan to 0, okay? I'm going to do it in 10 years. We're going to make 4 payments per year. We're doing quarterly payments. So what is the total number of periods? You just multiply those two cells, 10 times 40. In fact, I think I screwed up that formula that used to be in here, 10 times 4. I have 40 payments to make, okay? Our annual interest rate is 5.75. Now here's the important part. I need to know what that annual rate is for the periods that I'm dealing with. In this case, I'm dealing with quarterly periods. So I need to take the annual rate and divide it by the 4 payments per year to get a quarterly rate. Finally, what is the payment to pay off that loan to 0? Okay, so we have one function we haven't looked at yet, and that is the payment function. I use this all the time to help calculate loan payments. What is our interest rate? We have to keep things oranges to oranges, apples to apples. The fact that we're dealing with quarterly payments means I need a quarterly rate, 1.44. Don't click on the annual rate when you're trying to do quarterly payments. Comma, how many periods are we dealing with? It's 40 periods, not 4 years, 40 periods. Comma, what is the present value? The bank handed me $750,000 as part of a loan. Very nice, thank you. The future value is we're trying to pay it off to 0. And this is interesting. When we deal with investments, we tend to invest at the beginning of the period. When you deal with loans, you make your first payment at the end of the period. So when you do a loan for a car or a house, your first payment is covering at the end of the first month that you've had that loan. So for loans, you put 0 for the end of the period. And by the way, 0 is the default answer. So if you didn't put anything, it would have chosen 0. Okay, there is my quarterly payment, $24,785 for 40 payments. So in this scenario, what if you decide, oh man, I can only afford $22,000 because of the cash flow your business is generating or whatever. I can't afford $24,000. So the question becomes, if I only pay $22,000, for these 40 payments, how much would be left on the loan? What would be the future value of this loan? So we can use the FV function to answer that question. Again, we have to deal with the quarterly rate. How many periods? 40. What is our payment? The payment is the $22,000 coming out of our pocket. It's already negative. And what is the present value of our loan? $750,000, and we're making payments at the end of the period. I need a comma. So what would be the future value of this loan if we keep paying it off at $22,000 a quarter? You would still have $149,166 left at the end of 4 years. Cool. So then, next question. I can only afford $22,000. How many years would it take to get this loan down to zero? So we can use the NPER functions to calculate that. Now, we're going to do it over here, which is the number of periods, and then we can divide by 12 to get the number of years. So right here, we need our NPER function. How many periods is it going to take? So what's our rate? 1.44%. What's our payment? $22,000, because it's all we can afford. What's the present value? $750,000. What is the what is the future value? Well, we want to pay it down to zero. So it's zero. So you could either skip it or put zero or type whatever. And then again, because it's a loan, we're going to put in a zero here. And so we would have 47 payments. And then right here, I guess I already had the formula in there. I'm just going to take that, 4 payments per year. It tells me I can get it done in 11.8 years rather than the 10 that I was hoping before. I think I mentioned 4 years, so it's been 10 years, 4 payments per year. Finally, one more. I can only afford $22,000. I want to get it done in 10 years or 40 payments, so then how big of a loan can I get? What's the largest loan I can afford? Well, that is asking for the present value function. What is the present value of this stream of payments? I can't talk and type at the same time. So we start to see some similarities. What's our interest rate? How many periods are we dealing with? What is our payment? Negative 22. What's going to be the future value of this loan? 0. I want to pay it off. So you can type a 0 or ignore it. And then we put 0 here for the end of the period. And what is the present value of that loan? $665,000. So if that's what I can afford and I want to get her done in 40 payments, then that would be the present value of the loan the bank could give me. Whew. So we know how to generate the payment needed to pay off a loan. Now let's talk about how to create an amortization schedule for that loan. Basically, an amortization schedule is for every payment made, I want to know what is the ending balance after that payment. For each payment, how much of that payment went to interest for that period and how much went towards the principal for that period. And then we'll do it for the entire life of the loan. These are handy to be able to generate, especially if you borrow money from, say, a parent or just, not through a bank. You can generate an amortization schedule that you both can track. And so as you make every payment, everybody's aware what the ending balance is at the end of that payment. And if you want to pay off the loan early, you know what that value would be. So first, what's our scenario here? We have, maybe I'll zoom in just a little bit, a purchase amount, and we're going to put some money down. So let's just say this is a car. We're going to put $4,000 down on the price of that car. Well, what is the loan amount? Well, the loan amount then is the difference between the price of the car and the amount of our down payment. So now I have to borrow from somebody, a bank or a parent or whatever, $36,000. I'm trying to pay it off in 4 years, and of course there's 12 payments per year if we do monthly payments. This could be 4 payments per year based on our previous example if we were doing quarterly payments. So it's really, you can do semi-annual, which you'd have 2 payments per year. Anywho's, for the sake of this exercise, we're doing a 4% interest rate. What is the periodic rate, right? If we're doing 12 payments per year, our period is months. So I need to take that 4% and divide it by the number of payments, which is our 12. So that is our periodic rate. How many payments will we be making? Well, if it's a 4-year loan and there's 12 payments per year, it's 48. Now again, this is important. If we were doing quarterly payments, then it's 1% per quarter and 16 payments. But again, we're doing 12. So finally, we can calculate the payment for this loan. So we're going to go equal PMT parenthesis. What is our interest rate? Remember, we're dealing with monthly payments, so we have to deal with a monthly interest rate. That's going to be that cell there. How many periods are there? 48, because there's 48 months. Got to make everything apples to apples. Present value of the loan. This is what the bank handed me. Is there going to be a future value? Nope. We're going to pay it all off. It'll be 0. You don't have to put the 0. It would default to 0. And because it's a loan, we're making our payment at the end of the period. Put in a 0. Again, you wouldn't have to put that 0. It would default to 0. So you'd get the same answer whether you put either both of those zeros. And our payment is $812.85 per month. So that's the payment we would make every month for 48 months. Payment number 1. Let me show you how to fill this out. 1 to 48. You already know this, where I can drag down and fill the series right here. There's another way of doing it. I'm going to click on that number 1, and on the home ribbon, the fill button right here in the top right, series. This is in a column. It's linear, step value 1, stop value 48. We're going to go from 1 to 48 down this column by clicking in this fill series button. Boom. 1 to 48, and I didn't have to drag down. Payment number 1. At the beginning, before we make the first payment, what is the balance? It is the current loan amount. Make sure you select the cell and not type it in here, because you want your user to be able to change these numbers and those changes to reflect down here in your amortization table. Our payment is going to be the $812. It never changes, so don't forget to absolute that. The payment is the payment. It's always the same. What is the interest that is accrued in the first month? There's a function for that. There's several ways to calculate this. We're going to use the function that Excel has developed for this called IPMT, which is it will calculate the interest for that period. Now, what it wants to know is the parameters of the loan, and then what period are we talking about. So the parameters of the loan are, there's our rate. We need to absolute that because it never changes. And the period that we're interested in is the first one. So that we don't absolute, because when we drag this formula down, I want to know the interest during payment 2, payment 3, payment 4. How many periods are in this loan? 48. Doesn't change, so make sure you absolute it. Comma, what is the present value of the loan? $36,000. Doesn't change, so absolute it. And finally, is there going to be a future value? No. Is there going to be a type 0? Yes, I can leave them off. It'll default to 00 in both cases. And so our interest rate is interest is 120 that first month, because we have the largest amount outstanding balance after the first month. So how much of this payment goes towards principal? Obviously, I could subtract these two numbers. If 120 went to interest, well, the rest goes to principal. But I want to show you the function in Excel that will calculate this for us. It is equal PPMT. And it looks exactly the same. It wants to know the loan parameters that never change, and then what period are we interested in. So here we go again with the rate, absolute that. What period are we talking about? Right now it's period 1, and that's the only thing we don't absolute, because as we drag this formula down, we want it to go period 2, 3, 4, 5. And how many periods in the loan? 48. That doesn't change, absolute it. And what's the present value of the loan? $36,000. That doesn't change. Absolute it. Future value will be 0. Type is 0. Just hit enter. And there's our answer. If I select these two cells and look at the sum, it's $812.85. And notice that's our payment. So like I said, we could have subtracted those to get the same answer, but whatever. Now, what is the ending balance after that payment? Well, we take the beginning, and in this case, we're going to subtract the amount that went towards the principal. Very often I'll get students that want to subtract the payment, but that entire payment did not bring down the balance because some of it went to interest. And when I say the word subtract, this is already negative. So realistically, all I'm going to do is add that principal payment, and that gives us a new ending balance. We're almost done. Equal, we're going to say the beginning balance of payment 2 or period 2 is the ending balance of period 1. And now I can take these 4 cells, drag it down just one, and you want to double check that you absoluted everything. And if you didn't, you're going to get some funkiness right down here. So your payment shouldn't change. It's always the same. The interest should go down just a little bit because you have a smaller balance. The principal payment should go up just a little bit because you're paying less interest. And then, of course, the balance does what it does. Now that that looks good, we can take those 5 cells, select that just one. Once in a while I'll get students who will grab both of them. Don't do that. You're just after payment number 2 here, and I can double click and it will fill in the rest of our amortization table, and you'll know you've done it right if the bottom ending balance is 0. It's equally as fast to create an amortization table for a house loan as it is for a car loan. House loan very often are 30 years, and so you'd have 360 of these payments. But because of that fill series, I just start at 1 right up here, go fill series column 1, 360, and hit OK. Boom, that goes down. And then creating the first few set of formulas doesn't take any longer, whether it's a house loan or a car loan. And once you get to this line, you double click and it'll go down 360 as quickly as it went down 48. So really easy to create an amortization schedule for any loan. The next thing I want to show you is how to calculate the cumulative interest. Basically, it's a running total of the interest and a running total of the principal. So there is 2 functions for that. CUMIPMT kind of matches this one. And just to be weird, CUMPRINC, which doesn't match that one. I don't know why they didn't make it CUMIPMT, but whatever. Equal CUMIPMT returns the cumulative interest paid between 2 periods. So again, it just wants to know the parameters of the loan that don't change. So that's why you want to absolute them. The loan is the loan. We got 48 payments, and the present value is the $36,000 in this case. So those never change. So you want to make sure you absolute those. What is your start period? Well, in this case, it's period 1. And what is your ending period? Well, in this case, I'm doing the cum interest. We're going to do a running total of interest. But just to demonstrate something, what if I wanted the interest for the first year? Well, I would do start period 1, end period 12. So that would be 12 periods right there. And this time, for whatever reason, the type is not optional. You do have to put that 0 in. And so that would be the interest for the first 12 payments. And if I could go through here, 1285, 87, 1285, of course, if I format that, 87. So that works. That's the interest for the first year. Okay, in this case of our running total, what we're going to do is start period is 12. Our end period is also 12. As we drag this thing down, we're going to go start period 12. We want A12. We want that to be absolute. So A12 sticks. The ending period will have to be relative. And so we have the same number there as here, but watch this. As I drag it down, it basically added these 2. And as I drag it down again, it's going to add these 3. So basically, we're just creating a running total of our interest. And if you look at this formula, we have A12 that's fixed, absolute, and A14 is relative. So that will just keep moving down as we drag our formula. Cum principal is exactly the same thing. I will just go ahead and type it equal cum print right here. Same thing. What's our loan? Don't forget to absolute the parameters of the loan, the period, and the present value. Finally, what's our start period? It's going to be A12, but we're going to absolute the start period. And what is our end period? A12 again. I see I got a mistake there. There we go. And we do need to put in the type on these. Enter. So that is the principal payment. We will go ahead and format that with the $sign. We can drag that down, and now I'll grab both of these. So at the end of the cum principal, it better equal 36,000 because that's we've paid off the loan. So it won't double click because I have that blank row in there, so we'll just drag down, blank column I should say. And let's double check, 36,000, and we paid 3,000 in interest. That is our fee to the bank for lending us money. So speaking of fee to the bank for lending us money, let's talk about you lending the bank money or investing. So it doesn't have to be a bank. It can be a mutual fund. It can be stocks, whatever you're giving. I'm going to put this at 0 for now. You're giving some kind of investment your money, and they pay you interest for allowing them to use your money. Right? So it's kind of like you are being the bank to whatever you're investing in. And you want to be able to calculate what is going to be the future value of that investment. All right, so let's just say we have 0 money to start with, but every month I got a brand new job, and every month I'm going to contribute $500 into a 401k, some kind of savings account, and the annual percentage rate is 6%, we hope. You're estimating that. How much money can you earn on your money? Years invested, we're going to hopefully invest for 20 years. And how many periods are there? We're contributing monthly, right? So in this case, we're going to take those 20 periods times 12. We have 240 periods, 500 a month. What is the future value of that investment? So equal future value. Here we go. What is our interest rate? Be careful here. I've kind of done a trick on you in that we want that rate to match our, again, apples to apples, our contribution. And that this is an annual rate. We're making monthly contributions, and the interest we want to earn is on a monthly rate. So we need to take that annual rate and divide it by 12. So what was a little bit tricky is I didn't have the 12 on the cell right here where we could say, oh, the rate is 6 divided by 12. So we'll have to do it in our future value formula. How many periods are we going for? Well, I did put that here. So that's in B5. I'll just type it because I can't click on it. And what is our payment? Remember, even though it's our money that we're investing, it is a negative $500 is our payment because it's leaving our pocket to go to whoever we're investing. And finally, what is the present value? Nothing. We don't have any money, right? So we'll just leave that blank, and I'll put 0. And then finally, what is the beginning, or what is the type? This is an investment, and we invest at the beginning of the month. So this should be a 1. So the bottom line is, if you have an investment of $500 a month for 20 years, you'll have $232,000 at a 6% interest rate. So now, let's say you currently have $5,000 that you were sitting in an account, and you want to get that invested also. So that we consider as your present value. You have that today. You're going to invest that plus $500 a month. How does that change this formula? Really no different. We have our payment, negative B2. What's the present value? Originally it was 0. Well, now we're taking our money. The bank, in the past, the present value was positive because we were dealing with loans. The bank was handing us money. In this case, we are giving our $5,000 to the bank or whatever investment we're putting it in. And so it also needs to be negative. So it's important that these two signs match in this case where we're investing money, giving it to somebody. And at the very end, we have a positive value because whoever invested the money gives it back to us. And so we have a positive 248 when we're done. So now we have a present value, a payment, and then of course all the rate and the NPER. So that's how you calculate the future value of your investments. As I mentioned at the beginning, a lot of these functions are really handy for your own personal financial calculations.